A distance of 1 meter separates the centers of two small charged spheres. The spheres exert gravitational force Fg and electrostatic force Fe on each other. If the distance between the sphere's centers is increased to 3 meters, the gravitational force and electrostatic force, respectively, may be represented as, then we have a list of choices with different coefficients on the force of gravity and the electrostatic force. Now the key here is to realize that, maybe we'll do this in white, both the force of gravity, which is G mm over r squared, and the electrostatic force, which is K Q1 Q2 over r squared, both of these forces are inversely proportional to the distance between the objects in question squared. And I cannot draw this symbol. There we go. So we see that both are inversely proportional to the distance between the objects squared. So if we increase the distance by 3 times, so the distance goes from 1 meter to 3 meters, that means that the force will decrease by 9 times. So let's use the force of gravity for example. I'll take the force of gravity initially, so maybe I'll designate it with a 0 for the initial force of gravity when they are 1 meter apart. That'll be G m over the distance that we'll call r, where r is 1 meter. So the force of gravity initially will be G mm over r squared. Once we move the two objects to be 3 meters apart, we'll call this force of gravity nu. We'll have G mm over 3r squared, or G mm over 9r squared if we distribute that exponent, which is 1/9 times G mm over r squared, which was the initial force of gravity. So this would be 1/9 the initial force of gravity. Now you can perform a very similar analysis to find the same thing with the electrostatic force, since it is also inversely proportional to the distance between the objects squared. So both forces will be 1/9 of what they were before if we increase the distance to 3 meters from 1 meter. So we're looking at the force of gravity over 9 and the electrostatic force over 9. So these symbols Fg and Fe represent the initial gravitational and electrostatic force in the scenario, and so once we move the objects 3 meters apart instead of 1 meter apart, we'll take those initial values and divide by 9 to find the new values of the force of gravity and the electrostatic force.